Hi everyone, we're going to discuss the polar equation and graph by hand. Do you recall the form for polar equations are EP over 1 plus, for this one, EP cosine of theta. And this doesn't have a 1 here, so we're going to write it with 1. So we have R equals 10 over, I'm going to factor out a 5 to get 1 plus 4 over 5 cos of theta. So we're going to we rewrote our equation. Now we can find out all the info. Anyway, 5 goes into 10 two times. So basically we have EP equals 2, E equals 4/5, which is less than 1. So this is going to be another ellipse. And then to find the P, which is the distance of the units from the pole, we're going to have to set 4/5 times P equals 2 and multiply everything through by 5 over 4, which gives you P equals 10 over 4, which equals 5/2. So let's look at this equation again and discuss it. It's cosine. That means the directrix is perpendicular to the polar axis. Also, it's positive, so it's going to be, we're going to take this. Our units are 5 over 2, which is 2.5 units to the right of the pole. Okay, so basically let's go over here and graph it. I'm giving you more information than you probably need to know on this, and it can be a little confusing, but let's do that. So we have 2 over 1 plus 4/5 cos of theta. So basically my directrix is 5 over 2, which is 2.5, which is about here, and it's perpendicular to my axis, so I'm going to draw a vertical line here. It's perpendicular. Alright, and we're going to the pole here is there. And we know that our foci is going to lie on this right in here. So that's going to help us out. Now, we need to find the vertices. So basically, since we're on here, we're going to use pi for my angle and 0. So when you plug in 0, you get cosine of 0 is 1. So R equals 2 over 1 plus 4/5. So you change this to 0. Cosine of 0 is 1. And that's going to yield, let's see, 10 over 9, which is very close to 1. Put a little higher than 1. So this point here, I'll put it out here, is 10 over 9 comma 0. Now on the other end we're going to use pi, and we know that cosine of pi is -1. So I'm just going to change this to a minus. So it'll be 1 minus 4/5, and that's going to give you a 10. So I'm going to go out 10 here. Actually kind of had it there. So here's our vertices here. This would be 10 comma pi. Now on the y part, to find out this y area, I'm going to do pi over 2 and 3 pi over 2. Well, we know that cosine of pi over 2 and 3 pi over 2 is 0. So basically it's going to be 2. So pi, we're going to go up 2 here, and that's going to be 2 comma 0, and go to 3 pi over 2, and that's going to be 2 comma 0, because 0 is our, actually it's not 0, sorry. It's 2 comma, we plugged in pi over 2, so 2 comma pi over 2, and 2 comma 3 pi over 2. Now, go ahead and kind of connect this out. So I'll probably go out in here. Well, that's kind of the ellipse there. So now that you have the main thing, we need to know that what the length of A is. So basically, we know the length is going to be 1/2 of this 10 part plus this part. So it's going to be 1/2 of 10 plus 10 over 9, which gives you 50 over 9. So to get to the center, I'm just going to take my 10 and subtract that. So 10 minus 50 over 9. And that's going to give you 40 over 9. Whoops, sorry. 40 over 9. And what is that in between? That's in between 5 and 4. So 1, 2, 3, 4. So it's about here. Let's use black. There's your center. And then C, the focus is at here. There's one focus. And the other focus is going to be, since these are equidistant here, so the other C is going to be, let's do this, C equals 49 over 9, or 40 over 9 minus 0. So the second focus is going to be 40 over 9 plus 40 over 9 comma pi. And that's going to be 80 over 9. 80 over 9 is really close to 9. So put it right about there. And this focus would be 80 over 9 comma pi, because we're on the pi part there. And that's all. Thank you and have a nice day. Bye-bye.